So our first order of business would be to parameterize our curve. As you can see here, x squared plus y squared equals 9 would be a circle centered at the origin with a radius of 3. And so the parameterization for that, if we go counterclockwise, would be a 3 cosine and 3 sine. So there's our curve C that we're going to be integrating over. Now the entire circle is drawn from 0 to 2 pi. Well, since we already have the x equals 3 cosine t and the y equals 3 sine t, we will go ahead and convert our field into t's. So our field as a function of t then would be x squared, that would be 9 cosine squared, plus y cubed, that would be 27 sine cubed, and 2xy would be 2 times 9 is 18 cosine t sine t. So there's our field. Now, since we're calculating flux, we need to compute our normal vector. Now, to get the normal vector, we simply do the derivative of the y component with respect to t, the derivative of the x component with respect to t, and make this one negative. So then our normal vector would be the derivative of 3 sine t, which would be 3 cosine t, and the derivative of 3 cosine t, which would be negative 3 sine t, but with a negative on it, which would be positive 3 sine t. So there's our n. We need to do the dot product of f and n. So our integral would be from 0 to 2 pi. We'd have a 9 cosine squared times 3 cosine, which would be 27 cosine cubed. We would have a 27 sine cubed times the 3 cosine, which would be an 81 sine cubed times cosine. And we would have the 18 cosine t sine t times 3 sine t, which would be a 54. What would that be? Sine squared t cosine t. So there's the integral that we need to compute. Now I'm looking at these two terms and I'm thinking, these we could do substitution on, but that one's going to need some work. So I can take this one and rewrite this as a cosine squared t times a cosine t. I can change the cosine squared t into 1 minus sine squared t cosine t, and then I could do a substitution. And so if we let u be the sine of t, then du would be the cosine t dt. So we can take all these cosine t's, pull them out, and that would be our du. So the integral that we would have left would be a 27 and then 1 minus u squared, and 81, and then u cubed, and 54 u squared, and then the cosine t dt would just become the du. Now, if we do the conversion from t's to u's, we also need to convert our limits on our integral. We got here t equals 0, which would convert to u equals sine of 0, or just u equals 0. And we've got t equals 2 pi, which would convert to u equals sine of 2 pi, or u equals 0. And that's interesting. And so our new integral would be from 0 to 0. And since they're both the same number, it doesn't really matter what that comes out to be, because the integral is going to be 0.